little bit of prep for midterm because your midterm is tomorrow. But we're not taking a ton of time because a lot of the information we just went over the last couple of days. And just make sure you are familiar with all the prep questions from the beginning of class up through today's lecture. So, the prep we do from yesterday is actually prep for the midterm tomorrow. Also. So, yes. Double, how do you say that? Double for your money, bang for your buck. Oh, we're the same. Anyway, so. I'm gonna get like Ian and get the things all mixed up. Great. You're too young for that. Okay, so we'll do this from the mug and then we'll do some different questions later. So, if you remember, we were talking about governors yesterday. These fellows. And Parker, you're first up for the first question. So, it says, a power plant using a hydraulically controlled, that just means a normal oil governor, hydraulically controlled constant speed propeller is operating within the propeller's constant speed range at a fixed throttle setting. If the tension of the propeller governor control spring or speeder spring is reduced by movement of the cockpit propeller control, the blade angle will do what? Will blade angle increase, engine manifold pressure increase, RPM decrease, or blade angle decrease, manifold pressure increase, RPM decrease, or blade angle decrease, engine manifold pressure decrease, RPM increase. He's going Charlie. How many are in agreement? Some. Anybody say Bravo? Anybody say Alpha? How many say, okay, I'm confused? Alright, it's a confusing question because it's super wordy. However, if I were to say, so think about the speeder spring on the flyweights. So if we lift up on that speeder spring by the lever arms connected to the control in the cockpit, what are the flyweights going to be allowed to do?
Over speed setting?
Yes, go out over speed. So now, because of flyweights, the governor doesn't like that position. What will it do to blade angle to bring that back to increase the blade angle? So it's going to increase the blade angle, which now I have extra load on the engine. And what will that do to manifold pressure? Increase. And because we're increasing blade angle, now the RPM slows down to get back where we want.
Okay.
Question?
So, like we talked about the other day, if that governor control cable between the cockpit and the governor snaps,
Yes.
that's going to allow the spring to have full downward tension on it and bring the blades to a low.
And also, this little safety spring on top, not the speeder spring inside, this is always trying to tug this lever arm to the lowest blade angle. But the control cable has very easily overpowers it. If we lose that control cable though, then this little safety spring or return spring is what turns it to our low blade. Any other questions? That was a whopper of a one for that one. Okay. Leo. Why is the pulley stop screw? So we talked about or maintain engine RPM in the normal manner until the high pitch stop is reached, or remain in the full low pitch position. Excellent. Yep, that's gonna be in a full low pitch position. Question?
Yeah, what is that question being asked?
So, the scenario would be taxiing around on the ground where you have low power because you don't want to be riding the brakes. So, your throttle is pulled almost to idle or just a hair above. And what blade position would you be operating in on the ground? Yes, a low blade angle. So you're already in a low blade angle. And it has to be at a certain RPM before the governor can start to pick up speed. So in that non-governing range, or lower than the governor can govern, it just remains in that low pitch position, no matter where. I mean, there's a small area your throttle operates where that's happening, but
So what's the increased RPM position? How is that just way power back?
that is the propeller control. Pull forward, you're asking the prop for full RPM, but it can't because you have very low engine power. So it can't go any lower of a blade angle to get any higher RPM. It's just like, okay, this is where we are.
Okay.
Any other questions?
And it's low, it's low, the low limit because you don't have oil pressure. It's not.
So that would
you
depend
can't govern if it's your oil.
which, and also it can't physically go lower because of the stops. Yeah. Elijah. When engine power is increased, the constant speed propeller tries to function so that it will maintain the RPM, decrease blade angle, maintain low angle of attack, or increase RPM, decrease the blade angle, maintain low angle of attack, or maintain the RPM, increase the blade angle, maintain a low angle of attack. Excellent. So yes, try to maintain the RPM, do that by increasing the blade angle. And this is a curious thing. How are we maintaining a low angle of attack, do you think? Increasing our forward speed. Because our engine power is increased, so we're assuming we're up at cruise, and now by taking a bigger bite, we're efficient, or increase our forward speed, so that does bring our angle of attack low, or medium. But yeah, that's assuming something in there. Isaac. The propeller governor controls the oil to and from the pitch changing mechanism, or spring tension on the boost pump feeder spring, or linkage and counterweights from moving in and out. Going Bravo? How many agree? Uh-oh. All right, what answer do y'all think? Give me a oh, yes. So governor controls the oil to and from the pitch changing mechanism. What? So yeah, it's not directly connected to counterweights. When we reduce oil pressure, we allow the counterweights to take over. And the linkage to our pitch change mechanism is pushed by the piston, is pushed by the oil. So that's kind of a after result, but it's directly controlling on the governor flyweights is greater than the tension on the speeder spring, or tension on the speeder spring is less than the centrifugal force acting on the governor flyweights, or centrifugal force on the governor flyweights is equal to the speeder spring force. Bravo, he says. How many agree? Bravo. And what is the consensus? So on speed means it's happy, it's where it wants to be, so our forces are equal. Our flyweights are straight up and down, they're not leaning in or out, because our centrifugal force is equal to speeder spring force. David, what actuates the pilot valve in the governor of a constant speed propeller? Is it engine oil pressure, governor flyweights, or governor pump oil pressure? Greg, deflect. And Dan, what will happen to the propeller blade angle and the engine RPM if the tension on the propeller governor control spring, speed spring, is increased? Blade angle will decrease, RPM will decrease, or blade angle will increase, RPM will decrease, or blade angle will decrease and RPM will increase. Excellent. Very good. Because our speeder spring being pushed down, flyweights falling in, it's like, uh-oh, I'm too slow, so it decreases the blade angle, which increases our.
So how do we know that the flyweights are going in?
Because tension on the speeder spring is increased. So when that spring is being pushed down,
Down, not up?
correct, it's tension.
Does that close the pilot valve?
It'll depend if it's counterweight or non-counterweighted.
And the counterweight, drop it, would close the pilot valve?
It would, which way would oil be going if it's counterweighted to take a blade to a go blade angle?
More oil goes on.
Excellent. So it would open up for oil pressure to flow into the. Yep. So. Hello, buddy. So. Speeder spring being pushed on, shoving down onto the toes of the flyweights, pushing them down.
What did that bring them in? If
It
it's-
does.
Oh, sorry. Okay.
Yes. And then it's like, oh, I'm going low tension against the flyweights in the governor.
I wanna say Bravo, but because it's automatic.
Right, does moving the throttle
Like, so
change speed
moving
or RPM?
moving the throttle is going to change your RPM with your engine, which is then
Does
going,
it?
if it's a little, isn't it though? No?
Does the governor allow that?
You could change the pitch, for example.
So throttle gives more power, you're giving
Right.
more air mixture into your engine.
Right,
But the governor senses that power coming because it speeds up, and this all happens
right,
tiny fractions of seconds, you don't even notice it. Senses that, and it will eat up that power with blade angle to keep us at the same RPM.
right.
So, with that thought,
Charlie.
it is. It's a very confusing way of saying it. Because what do you actually do to change RPM in the cockpit?
Increase pitch.
Yeah, you just take the prop control and move it forward or after, whatever you want. But that prop control is going to the cable, that's going to the lever, that's going to the speeder spring to put more tension against the flyweights. So by the pilot moving that control in the cockpit, this whole series of events is happening. But, yeah, it's a very tricky answer.
But if it's, doesn't your governor control your blade angle compared to RPM of the engine? Or power output of the engine? You know?
Yes, it will keep the RPM wherever you set the prop control.
Right.
If you set the prop control for 2100,
Maybe I'm thinking back, the governor controls propeller RPM or engine RPM?
both, because these
Okay.
are,
Right.
I mean, extension of the crankshaft, you could think of it. Some of them are obscured, but yes, you can think of it loosely as an extension of the crankshaft. So by slowing down our big old prop, that's gonna slow
slow
down
the
our
engine
engine.
as well.
Yeah. Yeah. Corbin. When the centrifugal force acting on the propeller governor flyweights overcomes the tension of the speeder spring, a propeller is in what speed condition? Is it on speed, under speed, or over speed? Over speed. Sorry. The flyweights are going out. Charlie. The low pitch stop on a constant speed propeller is usually set so that the engine will turn at its rated takeoff RPM at sea level when the throttle is opened to allow takeoff manifold pressure, or maximum allowable engine RPM cannot be exceeded with any combination of manifold pressure, altitude, or forward speed, or the limiting engine manifold pressure cannot be exceeded with any combination of throttle opening, altitude, or forward speed.
Alpha?
Excellent. That is what it is set for. So you get rated takeoff RPM, but they test that at sea level with full throttle and within manifold pressure. gas sample pressure if you have prop at too high a blade angle, or, yeah, engine RPM. Yeah!
Is that because engine rate takeoff RPM will probably be the highest you'll ever see? Is that why you said that a low pitch is associated with, low pitch stop is associated with that?
Right, you want to achieve that. But you don't want blade angle to go lower than that. So you have to make sure you get at least that, but not lower than that, lower blade angle than that. Yeah.
And is that mainly to prevent reverse?
Yes, so you're not going into, now you're going through 0 to negative, but yeah. Sydney. What controls the constant speed range of a constant speed propeller? Engine RPM, or angle of climb and descent with accompanying changes in airspeed, or the mechanical limits in the propeller pitch rate? Excellent. That is mechanical limits. This was the first successful aircraft propeller governor designed by Elmer Woodward in 1934. So that's your historical tidbit of the day. Any questions on those questions? All right. And move. Feathering props. So, we have already talked about this some, but we'll go into more detail of how they work. The AOPA Propeller Safety Advisor has excellent diagrams and explanations of this stuff if you need to review at any time. Or, yes, it does actually at the end of it. And the Macaulay Tech Guide has even better illustrations and explanations. So hopefully by the end of this portion of lecture, you'll understand propeller feathering, unfeathering operations, and the mechanisms. Here is, anyone know what this aircraft was or is? B-36 Peacemaker. It's supposed to have 5 turning, but we got a problem. So what is the purpose of feathering? Reduce drag. When an engine fails in flight. So here we have full low pitch, there we have feather, and they want you to know that feathering propellers have the ability to rotate to approximately a 90-degree angle. And when our blade turns to that almost 90-degree angle, now we have a ton of drag and our engine will eventually stop rotating. And that's a cool picture too. So one of the things, there was some discussion yesterday of, well, why don't we make all kinds of speed props feathering? Well, this is a contrast between just a regular constant speed prop and the hub and a featherable hub, which these I took off the mock-up board so you can actually go look at them and compare them. We have a lot longer hub, almost twice as long, to allow for that full feathering blade angle change, to have the extra mechanisms. So we're adding complexity, we're adding more manufacturing, we're adding more weight, we're adding more inspection. So the weight, the expense, the maintenance is why they don't just do this to all props, because the advantage would be very minimal on a single engine aircraft. So the guts are similar. We start off basically with similar things as an and then a counterweight twist spring pressure to help to a high blade angle. And the whole way into feather. Now, how does it do that? So in the governor, and I'm gonna pass these two around so you can look at what I'm talking about. So it's gonna have an additional lift rod going to a pilot valve. This is a feathering governor because, we're gonna talk about this, it has a unfeathering component to it to take the prop out of feather. So this is an additional component for the lift rod on the pilot valve. On top of here, this is just nothing. So you can compare those two. So what happens is when the pilot moves the cockpit control, the prop control, back into feather, like we do on the King Air is more fancy because it's a PT6. This is more so for recip featherable props like Apache. So when you move that control into feather, it moves this beyond normal high pitch position and lifts up on the pilot valve. So now, instead of just oil coming, relieving pressure, all the oil is completely drained out so it can go beyond normal high pitch into feather. And it shows right in there our lift rod attaching to our control arm. So override the position of the speeder spring and flyweights, activates when pilot selects feather, and allows all the oil completely flowing out. And the propeller automatically feathers if oil pressure is lost. So if you lose all your oil pressure, prop goes into feather, which is what you want because your engine probably died. And it's a little bit hard to see on here, that's why I'm passing governors around, but this is a non-feathering, just flat on the top, nothing extra in here. But here we have our lift rod in there that this can move beyond high pitch position. Now, what do you think could be a problem? So on the PT6, it's a free turbine, so on shutdown, that prop can go into feather. Starter is running a compressor, not even attached to the prop, so no concern. Compressor comes up to speed, turbines come up to speed, then we got plenty of power to rotate that prop. What do you think happens on a recip if we shut down our engine with the blade in full feather? That's gonna be crazy hard to start. Some you can't. You have to manually, on the Apache we have giant paddles that fit over the blades and you have to undo some latches and then manually rotate it back to fine pitch if somebody isn't thinking and has it in feather. But some props do have a safety feature to keep it from going into feather at controlled normal engine shutdown. So there is a latch mechanism, and I have a really nice video of this in a little bit that illustrates it really well. So if you're not quite grasping it yet, that's fine. But latch mechanism prevents feathering at low RPM and ground operations. Also, there often will be a detent, especially on recips, or additional effort. You somehow have to bring your prop levers around something, included in the control to prevent inadvertent feathering. We're going to talk about PT6 later. That's a whole different animal, but this is for recips. And what happens is these little latches in here, normally at cruise RPM, this is moved out so the latches can't even engage. But then, when you're on the ground, now you have the blades in low pitch, so this moves in and the latches are held out by centrifugal force, so they can't engage when your prop is rotating like 1,000 RPM or above. But as you pull your power back, you're ready to shut down the engine, then your prop slows down and there's not enough centrifugal force to hold the latches out, so they fall in and lock the blades in the low pitch, so you can shut down, loses engine oil pressure, but the latches are holding it in low, so it can't go into feather. The video will show it really nicely. Another thing that some props, not very common anymore, maybe older aircraft or maybe experimentals, but you can have an unfeathering accumulator, and some will have this as an option that you can add. So it takes a special governor that can accommodate the accumulator, and the governor will charge the accumulator with oil. So next slide has some better diagrams. Charge this with oil. On the other side is a nitrogen charge, about 100 psi. And then there'll be a ball check valve to hold that oil in there. And then when the pilot wants to unfeather, it releases that oil to bring that blade to low blade angle. If you do not have an accumulator, then just normal governor oil pressure has to unfeather the prop on restart, and some, they don't got enough power to do that. And just different styles of accumulators, and these are something that a prop repair station would deal with pressurizing the nitrogen, with pressure testing it. They do have overhaul periods, so that's something you would send to the prop shop. We don't really do anything with them, just like governors. So what happens is, as you're in normal operation, the oil is kind of circulating through the accumulator. So this check valve is allowing oil to come in, pick out, staying at the pressure the governor gear pump is pressurizing it to. But as soon as you move the control to high RPM, that locks, that check valve closes, locks the oil that's in there, holds it in there. And then when you go to start up, it will release this and unfeather. I said that backwards. When you move the prop control into feather, not low blade angle. When you move the prop control back into feather, that's when it seals off the oil in the accumulator, holds it there, so when you move it out of feather on startup, then you have all this boosted oil pressure taking those blades to a low blade angle. That makes sense. I said that wrong the first time. Any questions on that? So here are some examples of where the accumulator might be, coming up through here, given oil through our governor. Any questions so far? So this is a specific prop that your textbook would talk about, a Hartzell compact feathering prop. So they found cool ways to make the hub a little smaller than normal feathering props. Low blade angle, oil pressure takes it to low blade angle like normal. High blade angle, internal spring counterweights. Now we're adding something in. Hartzell compact uses high pressure nitrogen, so this is not an accumulator. Accumulator also uses nitrogen to unfeather, but now we're using high pressure nitrogen in the hub to help us take it to a high blade angle. So if you're reading anything about nitrogen, make sure you understand, oh, are they talking about an accumulator or a Hartzell compact feathering prop? And this is something that you would service as a mechanic. The manual would set you through how to do that. And this is one that has the little latch mechanism that prevents it from going into feather at a low RPM, idle RPM when you're taxiing around on the ground. So this one, 800 RPM. If you're lower than that, it will engage the latch mechanism so it can't feather on the ground. Let me see how long this video is. Did I not write it down? Ooh. Let's watch the video because it kind of flow the thought right into there. Then I'll send you a break. Mousy, where are you? Come to me, Mousy.
When the aircraft is flying, we have the propeller in some positive angle, so that we can fine out the course. But when the engine shuts down, we want the propeller to go to the feather position. That's in flight. However, a problem might exist when we're on the ground. So let's assume the aircraft has completed its flight. It has come off the runway, has taxied in to the apron, and the prop pitch will be in fine or super fine angle. So be it at a very low angle. And then the pilot shuts the engine down. So he deliberately shuts it down because he wants to put the aircraft away for the night. Well, if the system senses an engine shutdown, the prop will go to the feather position. This is okay in flight. In fact, this is desirable in flight. But on the ground, this is not such a good thing, because when we want to start the aircraft the next morning, then the starter motor has to overcome all of this windage. So if the propeller went to the feather position when we deliberately shut the aircraft down on the ground, then when the starter motor goes to turn the engine over, if you can visualize the prop moving down this direction, the starter motor has to overcome all this windage. So that can make it difficult for the starter motor to start the engine. So what would be desirable would be if we were on the ground, when we deliberately shut the engine down, close the aircraft off for the night, that the propeller doesn't go beyond, say, superfine. So how can we do that? Well, we do that with start latches. Okay, so here I have a propeller, and it's in flight, and this is the piston that's changing the prop pitch. This is the oil pressure, and these are the start latches. So when we're in normal flight, the propeller is turning, and there's centrifugal force acting on the start latches, and that force is pushing the start latches out. Now let's assume that the engine fails in flight. So when the engine fails in flight, there will be a loss of oil pressure, the feathering valve will open, and then the feathering spring will push the piston all the way back to the feathering stop. And there we go. Okay, so that's normal flight, and that's what we want. The propeller is now in the feather position. Now let's assume that the aircraft has completed its flight. It's come off the runway, it's taxiing into the apron, it's come to its parking position, and we're ready to shut down. Well, when we're in the ground range, the propeller is in the fine or ground fine position. There are still centrifugal forces acting on the latches. However, once the propeller is back in this position, the start latches align with a latch on the piston. So when the engine shuts down, we'll have no centrifugal force keeping the latches out. There is a loss of oil pressure, but the spring tension here on the start latches pushes them out, and they hold the piston in position. So this spring here can't push the piston back to the feathering stop. So we have landed and we hold the prop in this fine position. So if I just go back, go through it again.
Hopefully that helped kind of illustrate was actually it's super simplified, but the little latches as it moves forward lock in.
So why does the latch engage when we turn it off and not when it stalls? Like what's causing it to do it?
So when you're like it is right now, that would be like up at cruise because you have some blade angle in there, so your pistons move back. But then when you have it in low blade angle, like after you land taxiing around, this moves in, so then these latches are lined up with that. And as long as you have it turning fast, you're holding centrifugal forces keeping them out. But as soon as you start slowing your prop down, and they engage.
So if you're in cruise at idle,
Yeah, then
then there's a chance it locks.
If you're in cruise at idle,
How about if you were,
how would you be in cruise at idle?
Say you're descending and you just pull power to idle.
Oh,
and then the
okay.
engine quits.
but your pitch would have to be very low for it to work.
Right.
It needs to be all the way
And
down.
as long as your prop is spinning, now they'll be set different ways, but probably centrifugal force be keeping these out. Also, manually feathering a prop is going to override this.
Okay.
So if you were at full flying, close to the ground, climbing out, and you're doing, ground maneuvers,
well, suddenly we're in a situation where we really need more power, climbing out, engine quit.
So if you lose oil pressure, this is going to go whew. Why are you still having enough RPM that these have not engaged yet?
It happens to engage on the top when you're losing oil pressure as well.
So then you are asking for a fine pitch. So we're up here. Governors send in oil. Then you reduce power. So now it's slowing down. Governor's still holding it. Fine blade angle. Those latches are lined up. And as it slows down, they're engaging because you're slowly slowing down. That makes sense? And again, this is very, very simplified. There's lots of stuff that's removed from this. But just to kind of understand how the latches work.
so if you turn the key off, while you are, whatever, have some RPM, you have to go and, hold it, not hold pitch, or go to full feather, or then there's a way, for staging is slow.
Turn the key off?
If you turn your mags off,
Okay. To shut.
at a certain RPM above idle.
I'm trying to think this through. Because this isn't, it's not something you would do. You would kill the engine with mixture.
Yeah, but that is a way you could get it
I
not
wonder.
hold it.
It's slowing down. other questions now, and then we'll finish up after break. Okay. Come back at 35, get some coffee, get some nice rainy, humid air in your lungs. I didn't think about that, Leo.
Are you serious?
If I understand the system right, not that you'd want to, but you could.
Right.
Let's say someone accidentally turns it off at 2,000 for whatever reason. At that
I
point,
think so, yeah.
probably.
Because that is simulating an engine failure, yeah,
So for it to work, you gotta first lower your RPM in low pitch,
correct,
and then
Correct.
see the loss.
yeah, yes. And that's probably when you need to get out the big old blade paddles to crank it back on the feather.
So, I think I'm still slightly confused. I think I've just figured out after today, that you compress the spring, you wanna, you put more oil in. More oil pressure when it's counter. Right.
Compressed spring, flyweights, and
Well, okay, let me back up.
I always have to like.
If you compress the spring, maybe I shouldn't say pressure, because that'll vary whether it's counterweight or.
It does. Yep.
Basically, you want to increase the RPM of the
Correct.
product.
Correct. Yes. That's a very good way of thinking about it.
So, I guess I'm confused, what are the flyweights doing?
They
Like, if we're compressing it by the throttle, not throttle, prop control, right, it's prop control.
correct.
Is that? Are the weights? So, prop control, pull forward, compressing it the most there, which you can see there, like the galley things open, right, that's how it's. In this one, you would be sending oil in, I believe.
So
I don't know if that's a
yep, there's two slows. We're gonna decrease blade angle. So in a counterweight prop, yes, it would be pushing
counterweighted.
oil.
If you go throttle up, oil comes in. The blade angle is lower.
Correct. Because counterweight.
Yeah, so you wanna increase the speed. So yeah, how do the counterweights, how are they interacting?
Or the
Why-
flyweight.
Yeah,
Yeah.
flyweights.
So that's all, the bottom of the speeder, spring, and the toes of the flyweight, that's all working with the pilot valve. But,
These, is it right there where they're like touching?
yeah,
Okay.
so, and normally, well, always, the flyweights are sensing engine speed, so normally if our,
Because
that's,
it's directly,
exactly.
yeah.
So if our, let's say we push the airplane into a climb, that makes our engine work harder, so it starts to slow down. Then the flyweights would fall in, and it would lower blade angle, keep our RPM the same. So,
It was more engines.
or what did I say?
engines-
Would lower
No,
blade
no, I'm
angle.
just gotta think through it. The engine would, you have a heavier load in the engine, so it
Yep.
slows down. Therefore, you'd want to, have a finer pitch.
Correct.
Which in this case, if it's counterweighted, you'd want to pump more oil in.
this for now. What's happening on our governor? I see you thinking. Well, a little more different, but it is with a pilot valve.
Spring tension, getting crank. I got it. It's a move.
No, opposite. Oh, Josh, you can think about this. So, I'm in a hard silk compact, not in the prop, but I take my controls, move them to feather. What is happening on the governor? Anybody's thinking it through with this governor. What is happening with the pilot valve? Completely releasing the tension. So that's when the pilot valve lifts up beyond normal high pitch. Yeah, high blade angle. So what is happening with the oil that would, the oil pressure is normally taking us to what blade angle? Low blade angle. So what is happening with any oil in the hub? It is going out, out, out. We are dumping that. And what is cranking us, taking us into full feather? Counterweight, springs, and nitrogen. You all, that answer, get gold star. So, governor releases all the oil pressure from the hub because it lifts the pilot valve up beyond normal high blade angle, and then counterweights, nitrogen, springs take us, boom, to feather. If, now this is rare, if we have an accumulator, what is happening with this little check valve when I move the controls into feather?
It's storing oil pressure.
Exactly. Check valve says, oh, oil, stay in there, closes off. Boom, holds that oil in there. Then, okay, now, load up our passengers, one take off, and I start up, put my controls full forward. What is happening with my governor? What is it doing with oil? Sending that oil into the hub, and if I have an accumulator, what is happening with that? It's dumping that, helped out by the nitrogen, boom, boosting that pressure to, boom, take us to the low blade angle. Nice.
So with the accumulator, the gas and the oil side, when you start the engine, does that oil pressurize it back through when it's running? Like how does it refill or move back?
So that is, it's two separate compartments.
So after, like, let's say you use it,
Yes.
how does it refill?
So it is, so it's with this check valve. It's going to allow oil to flow to a certain pressure and then
So it's using the engine oil.
flows somewhat, yes.
But is it routed back from the prop?
It,
Like, is it series with the prop, or is it
so we think more of the governor.
series with the go?
Yeah, yes, because flowing, normally, flowing through the governor, accumulator, prop, like, yes. So yes. And then, yeah, keeping that pressure in there. When it senses feathering position selected, that closes that, holds that pressure.
This might be, I'm not sure exactly what David asked or Tom, but the accumulator, is that feeding right back the other way, right
Back
from here?
through the governor, through an extra passage. Yes, because he has special, unfeathering accumulator adaptable governor. Not all governors have those extra passages. And decrease blade angle, depends how powerful of an engine you have, if that actually works. And accumulator may be used on some aircraft. Any questions? Okay, I have a few questions for you. Zach, what normally prevents a hard sole compact propeller from going to feather when the engine is shut down on the ground? Is it propeller cylinder air pressure, or a latch mechanism composed of springs and lock pins, or an accumulator provided oil pressure? Very good. It is a latch mechanism. And Josh, manually feathering a hydromechanical propeller means to block governor oil pressure to the cylinder of the propeller, or port governor oil pressure to the cylinder of the propeller, or port governor oil pressure from the cylinder of the propeller. I can reword it if you want me to. So,
See?
you got it. You did it, less than trick you. So, nice guess. You look guilty, so. You don't know. If it's feathering, it's going to be counterweighted, so the counterweights take it to a high blade angle, so that's when we get rid of that oil out of the cylinder. So you should now be familiar with propeller feathering and unfeathering operation. And I think that's like